Greetings and welcome to the AOCS Student ePoster Pitch Competition. I'm very excited to be here today. My name is Dr. Jim House. I'm a professor in the Department of Food and Human Nutritional Sciences at the University of Manitoba in Winnipeg, Manitoba, Canada, and I'll be acting as your moderator today for today's event. We are excited to bring you our student poster pitch competition at the Sustainable Protein Forum. The competition will take place in two parts, with the first part of the competition occurring today, and part two of the competition will take place tomorrow, September 28th at 11 a.m. Central Time, following the similar format as we're using today. The winners, however, will be announced during the live forum, which is actually happening in Chicago during the period of October 4th to the 6th. And so we're looking forward to seeing those that are present in person as well as virtually at the AOCS Sustainable Protein Forum. We're looking forward to the student presentations, hearing the feedback and questions from the judges, and seeing the participation from our live audience. And we have 4 excellent judges that have agreed to participate in today's process. We have Carrie Campbell, Elaine Crew, Mahfuzur Rahman, and Chris Marinangeli. And I want to thank those judges for devoting their time and dedication to this process. We wish the students well and thank our volunteer judges from the audience for attending, listening, and supporting this competition. So this is what will happen today. Each of the 4 competition finalists will present for up to 5 minutes. They may use a visual aid like a PowerPoint slide, but not their actual ePoster. That was already, so that will be assessed at an alternative time. If you would like to view the entire ePoster, however, you can visit the Sustainable Protein Forum website where it is available. After each student presents, a 7-minute question and feedback session will take place. So please post any questions, comments, or congratulatory notes in the chat area. And we'll use that as an opportunity to ask questions and additional feedback during the actual process for today's events. After all of the 4 presentations have ended, we will bring all the finalists and judges back on screen for a last round of questions. At that time, we will open up an audience poll so you, our live audience, can vote for your favorite pitch. And the audience vote counts towards the final score. So I encourage you to be engaged and vote for the presenter that you feel has provided the most optimal presentation today. So with that, I'd like to start by introducing our first presenter. And let's get started. Presenting first today will be Mohammed Zubair, and he will be presenting his talk entitled Keratin Derived Sustainable and Green Bio-Adsorbents for Heavy Metal Ions Remediation from Polluted Water. With respect to Mohammed's background, he attained his M.Sc in Bioresource Technology from University of Alberta, where he's presently pursuing his PhD degree. During his master's studies, he worked on the development of bio-based food packaging materials. His current research focuses on the development of bio-based absorbents for water purification. So Mohammed, I would invite you to share your screen and unmute yourselves, and we look forward to your presentation.
I want to start my presentation with one of the famous quotation of Benjamin Franklin. Once he said, when the well is dry, then we will know the worth of water. He is absolutely right. According to World Health Organization, 2.1 billion people don't have access to clean drinking water. And 1.5 million people die every year due to unsafe drinking water. Although we are living in an industrialized world, but the amount of wastewater produced from industrial and agriculture sector is about 1,500 cubic kilometers, which is 6 times more water than available in all rivers of our planet. If we just talk about heavy metal contamination, alone arsenic has nearly affected 140 million people in 70 countries of our globe. The existing technologies are very expensive and cannot be implemented in industries with limited resources. So we need a solution that should be cheaper, environmentally friendly, and can be implemented on a larger scale. Here comes my research project to decontaminate the wastewater using chicken feathers. Now you may be curious to know why specifically the chicken feathers. Chicken feathers are basically poultry byproducts. Every year, millions of tons of chicken feathers are produced worldwide, which are either landfilled or burned and creates environmental pollution. However, chicken feathers are consist of above than 90% of keratin protein, and we can use them to develop a adsorbent for water purification. Now comes the question how we can treat the contaminated water using chicken feathers. The process is simple and pretty straightforward. And to answer this question, we need to understand the basic chemistry of the chicken feathers. Chicken feathers have keratin, which are cross-linked by a disulfide linkage. By breaking these cross-links and introducing nanochitosan into it, we can increase the surface affinity of the chicken feathers so that their adsorption performance for the heavy metals can be enhanced. In order to develop this adsorbent, we took chicken feather, washed, oven-dried, ground, and with the help of hexane, lipids were removed. After the removal of lipids, chicken feathers, keratin was dissolved using reducing agents, followed by the addition of nanochitosan with 1, 3, and 5%. Then this mixture was sonicated for 2 hours and then dialyzed and dried to obtain the chicken feather keratin nanochitosan derived biosorbent. After the synthesis of this biosorbent, the biosorbent was characterized using different techniques, such as X-ray photoelectron spectroscopy. This technique was used to see the chemical bonding status of the neat chicken feathers after the incorporation of nanochitosan into it. If we see the graph, both bioadsorbent and neat chicken feather keratin have 3 distinct peaks. However, after the addition of nanochitosan into the keratin, new distinct peak appeared that belongs to the ester at 289.05 binding energy. That peak shows that the interaction or the chemical bonding has been introduced between nanochitosan and keratin. That might be the reason to increase the bioabsorption capacity of the keratin. Furthermore, the morphology of the chicken feather keratin was observed after the incorporation of nanochitosan. The neat chicken feather keratin have long shaft and smooth surface. However, after the incorporation of nanochitosan, the surface of the chicken feather keratin turned into rough and also ruptured. After the successful characterization of these chicken feather keratin derived biosorbent, their bioabsorption performance was assessed using ICP-MS, inductively coupled plasma mass spectrometry. For this purpose, laboratory synthetic wastewater was used for simultaneously removal of 8 different metals: zinc, nickel, lead, cadmium, cobalt, arsenic, and chromium. From this graph, it clearly shows that our study has 3 outcomes. Firstly, our biosorbent have excellent adsorption capacity as compared to the neat chicken feather. And secondly, our bioadsorbent shows adsorption capacity for the arsenic and selenium up to 99%. And thirdly, this adsorbent is environmentally friendly and can be implemented at a larger scale. And this bioadsorption capacity of the chicken feather keratin was enhanced, and the bioadsorption capacity was observed due to the presence of electrostatic and complexation interactions between a biosorbent as well as the metals. At the end, I would like to say, with the development of this adsorbent, we can reduce the potential health and environmental impacts even before the risk of occurrence. Thank you.
Thank you very much, Mohammed. Excellent presentation. Judges, it's now time for your feedback and questions. And also for those in the audience, if you have questions, please put them in the live stream chat. So I'll just move forward through the cycle and ask our judges if they'd like to start with questioning. Perhaps I'll start with Elaine. Would you like to ask a question at this time?
Sure, that was a very nice presentation and very timely. Mohammed, is there a certain saturation? Like, is there a critical a process for making the chitinized chicken feathers? Is there an optimal level, or do you maximally use all the sulfur that's available for binding?
I mean, I just checked for the 100 ppb and 600 ppm ppb
Okay.
To check the adsorption capacity. But I believe there might be a possibility if we go up, maybe 1,000 or 2,000. We haven't checked for the adsorption, but why we do like 600 or 100 ppb, because the industries we are partnering with them, they're like the requirement is around 600 ppb, but there might be a possibility that that adsorbent may absorb more.
Okay.
But we haven't checked that one.
Yeah, this one. Thank you.
Okay, thanks, Elaine. Carrie, perhaps I can ask you if you have any questions for Mohammed.
Yeah, I was interested in your process for preparing the keratin fibers for absorption. You had a lipid removal step. I was wondering how does the lipid interfere with binding? How important is it to remove the lipid from the feathers? Is that something that's absolutely, yeah?
Yeah, we remove the lipid using hexane. That's your question?
Well, I was wondering what's the purpose? What happens if you don't remove the lipid? What happens if you keep the lipid in?
So we want exactly only the proteins, because if there is a lipids, it will also restrict the interaction between nanokitosan with the proteins. So that's why we just pure keratin proteins, because we are targeting only the proteins. The proteins will actually absorb the metals. So that's why we don't want lipids that might be reduce the potential absorption of the keratin towards absorption.
Okay.
Okay, thanks, Carrie. And Mahfazur, would you like to ask some questions at this time of Mohammed?
Thank you, Dr. House. So this is very nice presentation, Mohammed. So at one point during the preparation of keratin, you have used sonication. So what is the purpose of sonication?
So sonication was basically used to activate all the molecules or the polymer chains to increase the interaction between the nanokitosan and the keratin protein.
Okay. Did you compare without sonication? Is there any conjugation without sonication?
Honestly, I did not do without sonication. I mean, I believe that without sonication, I haven't checked without sonication, honestly, but because the sonication caused more activation of the molecule. So that's the reason we used sonication.
Thank you.
Okay, thank you. At this time, I'll just remind our audience that you can ask the questions in the live stream chat. So I encourage you to include your questions there. And these can be asked either during the actual individual session or towards the end of the overall session today. While our audience gathers some thoughts and questions, perhaps I can ask you a question. I was wondering, as Carrie mentioned, you were using a defatting process and you used hexane. Can you maybe explain why you used hexane as opposed to an alternative solvent that might be a little bit more greener, as it were?
I would say the hexane is the cheap one, so that's the main reason to use that. But
do you know if alternative solvents could have an impact on the absorbent properties of the final protein? Is that something that may be worthwhile investigating as you move forward with this process, this project?
I would say we can use other solvents too, but those are usually used in the mixture like chloroform and with others. So I would say that's the best one from the studies that we found. So that's why I use the hexane only. But we can use other greener too. But yeah.
Okay. Yeah. Any other questions or thoughts from our judges today? Maybe just if you do, maybe just raise them at this point in time.
Just a quick question, do you know any like what type of like organic or greener defetting other than hexane we can do?
We can use methanol and chloroform mixture.
Okay, thank you.
If there's time for a question, I was just wondering, Mohammed, how scalable is this? What are the volumes that you're currently working with right now? And is this scalable on an industrial way?
Yeah, so far we checked only with the 10 ml, the initial study, but we are now scaling up around a liter. But still we are working with that because we need a reactor and everything for that. We are working on that one.
Okay, thank you.
You chose to use chicken feathers. Are there alternative keratin containing substrates that might be useful as well?
Yeah, so the hair, nails, hooves, so many other sources, right? So why we picked chicken feathers? So, you know, the keratin has disulfide linkage. So if we subcategorize the keratin derived sources, so I would say the keratin from chicken feathers have medium or optimum level of disulfide linkage. And, you know, we need to break those disulfide linkage before modification. So we were looking for something which have disulfide linkage between those sources, like hooves have the disulfide linkage more as compared to chicken feather, and some of them are like lower in disulfide linkage. So we selected chicken feather because of the disulfide linkage between extreme and the very few number of disulfide linkage.
Okay. Well, thank you, Mohammed. Our time's up for this session. I want to thank you for your presentation and for answering the questions. And we'll get ready to move on to our next presenter. And welcome back. Our second finalist today is Jannatul Ferdous, and they'll be presenting toward an integrated framework of process optimization based on technical, economic, and environmental performance criteria, a case study on pulse protein processing. Jannatul is a second-year PhD student in interdisciplinary graduate studies at the University of British Columbia, Okanagan. And her PhD research is focused on life cycle assessment and techno-economic analysis of pulse processing pathways in Canada to promote more sustainable and optimized pathway to obtain pulse protein. So Jannatul, I invite you to present your findings today, and you have 5 minutes to do so. So welcome, and the floor is yours.
Thank you so much. Good morning, everyone, and welcome to my presentation. It is very common that we conduct either life cycle assessment or techno-economic analysis to assess the feasibility of any processing pathways or technologies. But it is high time that we should consider both LCA and techno-economic analysis to assess the pathways to get an overview of their technical, economic, and environmental performance. So there are numerous studies that integrated these two methodologies to assess different processing pathways, but there is none for the agri-food processing industries. So we conducted a systematic review to identify the key considerations of these integrated frameworks, and we developed an integrated framework especially for pulse protein processing pathways, but this integrated framework can be used for any other agri-food processing pathways. So our review questions were that what are the required methodological choices for integrating LCA and TEA, and what is the current state of the art of LCA and TEA studies of agri-food processing pathways. Based on the findings from these two review questions, we have identified the gaps and limitations of existing integrated frameworks, and we answered this question that is it necessary to develop sector-specific frameworks. And we developed this integrated framework, which can be used for agri-processing pathways. So we have used the Web of Science platform for our initial search, and after title, keywords, and abstract screening, we have got our final sample size. For review question 1, it was 66 research questions, and for review question 2, it was 22 research questions. And from these questions, we have answered the key considerations they have used, and we have found out some characteristic elements for the LCA and TA studies of agri-food processing pathways. So our summary findings were there is no integrated framework for this sector, and it is very common to use different system boundaries for LCA and TEA and different functional units also. And for economic analysis, discounted cash flow analysis, net present value, internal rate of return, they are mostly used. And process simulation based on mass and energy balance was very common in the techno-economic analysis studies. And so when we try to integrate process simulation with life cycle assessment or techno-economic analysis, first, we have to define the system boundary and perform the process simulation. In any simulation software, we can use Aspen Plus, Super Pro Designer, or ProSim Plus. And then we should obtain the mass and energy balance. And from this process simulation output, we can develop the life cycle inventory and our capital and operating expenditure data inventory. And after that, we can characterize the environmental and economic impacts of the processing pathways. So our integrated framework, the first part is basically the system flow diagram of pulse processing pathways. So dry fractionation and wet fractionation are the most common two pathways for getting the protein from any plant protein crop. And so as it is very common to use different system boundaries for life cycle assessment and techno-economic analysis, we followed that trend, and we have employed multi-objective sustainability analysis and genetic algorithm for multi-objective optimization. We have integrated GIS models and AHP with that, and at the end, it will integrate uncertainty analysis and sensitivity analysis for that. It will enable us to perform a multi-criteria decision-making for getting sustainable and optimized processing pathways for pulse industries. Thank you.
I'll now turn it over to our judges who are prepared to provide some feedback and questions. So judges, the time is yours, and perhaps I'll go in reverse order this time and ask if Mahfuzur has any questions at this point in time for Jannatul. Thank you.
Thank you. This is a nice presentation, of course. And very interesting study. So at some point you said like your study can be utilized for other agricultural crop. So I'm wondering, like, you have studied, you have one type of legumes. The legumes have, like, we have different type of, like, some are high protein, some are low protein, some are high fat, some are low fat. Like if we compare the pea with soybean, would it be similar?
Um, no, the protein content are different based on the crop type, but the process to get the protein from this protein crop are quite similar. They basically use the dry fractionation or wet fractionation process, but the final output are different based on the protein content, but the processing system are quite similar for other protein crops.
So for example, if we take pea protein, they do not do any defatting, right? So, and if we take soybean, there is a huge amount of oil extraction and defatting sometimes. Like, how can we compare this process?
Actually, defatting can be included as a unit process in this process flow diagram, right? So the detailed process flow diagram can be quite slight different from each other, but the whole whole methodology, like the process simulation and optimization, that are quite similar.
Thank you.
You're on mute, Jim.
Yep, I was just about to unmute myself there. Carrie, I'll turn it over to you. Thanks very much.
All right. Thanks for the presentation. I was curious what your thoughts are on doing the life cycle analyses and techno-economic assessments are really interesting from a high strategic level perspective. I'm curious what your thoughts are on, what would you do with this information if you were, either an industrial researcher or a governmental entity? Where would you like to see this this integrated approach utilized, and what do you think would be the product of this in industry in general?
Okay. This project is related to my PhD research, and one of the outcomes will be we are developing a publicly available inventory dataset, which will be facilitate benchmarking the industry from the sustainability profile. So, and this project is funded by NRC, a government entity. From the government perspective, I think there should be a regulation for the industries that they should at least set their process to balance with the average benchmark dataset. And we are also trying to develop an online tool where the industries can input their data and can get an overview about their sustainability status and can get an idea about how they can optimize their pathways. So from industrial perspective, the outcome of this framework will be that they can know their status and they can improve their pathways following based on the results from that online tool.
Thanks, Carrie. Elaine, would you like to ask a question at this time?
Yes, that she partially answered, Jannatul partially answered one of the questions I have. So if you have this algorithm that you can develop with all this data, is there a way, for instance, for companies, if they say they valorize co-products from their stream, is that going to impact in your model? Is that accounted for? So when, Mahfouzar was mentioning the lipid extraction, while the processing creates more issues, it also generates the oil, which has value, and it's using a co-product. So, or protein may be the co-product for an oil seed. So how does that work in your model?
Okay, the pea processing pathways has also some co-products like the pea fiber and pea starch. And but the life cycle assessment we are carrying out is kind of an attributional life cycle assessment. So we are not focusing on the co-products right now, but one of our objective of our research is to develop a consequential life cycle assessment, where we will try to characterize the environmental impacts associated with these co-products and how the market will change if the supply of these co-products will increase. Like if we produce more pea proteins, it will produce more pea starch and pea fiber, right? So it will have an impact on other starch and fiber because they are very demanded as gluten-free starch and fiber. So we will carry out a consequential life cycle analysis to identify that impact too.
Okay, I thank you very much, Jannatul, for your presentation, and to the judges for asking your questions. And at this point in time, we'll move on to our next presentation. Thank you very much.
Thank you.
Welcome back. Our third finalist is Simone Vivek-Alpiger, and she'll be presenting the talk, Functionalization of Rapeseed Protein Using Membrane Filtration. As a bit of a bio, Simone has a background as an M.Sc in Dairy Science and Technology from the University of Copenhagen. In her current position as a PhD fellow at Aarhus University, her research is concerning modification and functionalization of rapeseed protein in order to create more sustainable protein ingredients. So with that, I'll welcome Simone to give her presentation, and the floor is yours.
Thank you for the nice introduction. We can all agree at this conference that we need sustainably processed plant proteins. And the current standard methodology is to extract plant proteins by alkaline extraction and isoelectric precipitation. And to purify these fractions further, we use membrane filtration. And this results in highly purified ingredients, but also high resource usage. So therefore, our approach is to use milder process treatments such as aqueous extractions that results in less refined protein ingredients, but where we use membrane filtration as a tool to tailor the functionality of these unrefined feed streams. But how do we create these filtration processes or design them? This is really a question like the chicken and the egg. On one side, we need to know how membrane filtration affects the composition of our protein matrix. And on the other side, we need to know how the composition of our protein matrix affects our filtration performance. So would you believe me if I told you that the composition of these two protein concentrates are the same? They're both derived from rapeseed, whole rapeseeds, and they have the same ratio of protein and carbohydrates, but as you can see, the structures are quite different. And when we change the colloidal size and structures or interactions in our protein concentrates, this might also affect the outcome of the filtration process. And therefore, we wanted to, or the aim of this research was to create an experimental design that could help us to understand how we could use membrane filtration to change the functionality of our protein concentrate. And secondly, we also wanted this setup to, or we wanted to investigate how the composition of our protein concentrate affected the membrane filtration performance. So to answer the first question, how did filtration affect the composition? In this case, we used a almost defatted rapeseed protein concentrate and where we had degraded the carbohydrates. And we filtered it through 3 different membranes with different pore sizes. And what we found out was that we could use an open UF membrane to fractionate napin from the remaining rapeseed proteins, and thereby create two fractions with different functional characteristics. And what's a bit interesting to notice here is that theoretically, napin and oleosine has the same molecular size, but oleosine is being retained by the open UF membrane, which tells us that this is not a single protein that we're dealing with in these unrefined protein streams, but it's actually a complex colloid. And therefore, it just emphasizes that we cannot design these processes based on theoretical values when we're dealing with these unrefined streams. The second research question was, how did the composition affect the filtration? And the traditional answer to this would be based on flux values. But these values does not really tell us anything about which type of material that is fouling on our membranes. So therefore, we introduced two new methodologies. We used confocal microscopy to look into the composition and also morphology at the surface of the membrane after filtration. And here we could see that protein and lipids were the major components in the surface fouling layer. And to investigate which type of material that was blocking the pores after filtration, we used TGA analysis. And by simply burning off the membranes while recording the weight, we get a unique fingerprint. And if we compare new and a used membrane, we can get an idea of how much organic and inorganic material is being entrapped inside the membranes. And if we then compare the three membranes we used in this study, we can see that even though the feed stream of our were the same in all cases, it's the same protein concentrate that we filtered through, it has the same composition, but we can see that the fouling material has different compositions. So to sum up, we created an experimental design where the chicken meets the egg. We created a design that could help us to evaluate how filtration processes can be used to evaluate, how we could evaluate filtration processes based both on ingredients and also a process point of view. So in the future, we would like to use the same setup, but on different protein concentrates with different structures. Thank you.
Thank you very much, Simone. That was an excellent presentation. Judges, it's time for your feedback and questions again. And this time I'll ask Carrie to go first with your questioning. Thank you.
Okay, interesting presentation. I've done a lot of work on characterizing fouling and on membranes, so I was interested in this one. I was wondering, were you able to differentiate, between surface fouling and internal fouling of the pores with these techniques?
Yeah, actually, we only looked at the surface of the membrane with confocal microscopy. And when we did the TGA analysis, we actually washed the surface fouling layer off before we measured what was inside. So yeah, I think we could distinguish.
Yeah, because that can always tell you a lot about the mechanisms of fouling and how you can avoid that. So that's interesting. Okay.
Yeah. Maybe I should get some good ideas or advices.
Are you finished, Carrie, or would you?
Yeah. No, I'll let someone else ask questions.
Okay. Elaine, how about we move to you? If you have questions for Simone?
Yeah, that was excellent. I was very interested in that. So have you tried different membrane compositions? I know there's a variety of different types of membranes. You mentioned, just the cutoffs, but I was wondering ceramic versus other kinds. What type of membrane, and do you find that there is a difference with the fouling, reduced fouling with any particular type?
We in this study, it was all polymeric membranes that we used, but we actually, it's not presented here, but we looked into hydrophobic versus more hydrophilic membranes as well, where we could actually see some differences, minor differences that could be, interesting to look into.
Okay, thank you. And then, Officer, do you have questions for Simone?
Thank you. Great presentation. So what is the difference, like if I do defatting or non-defatting substrate through the membrane, like how much it impact on the fouling?
In general, lipids or fat is trouble to membrane fouling. And prior, it's actually a protein concentrate that we extracted ourselves from whole rape seeds, where it's like almost a fully defatted system. A solventless defatting, but we use centrifugation and different pHs to remove the lipids. But what's interesting to notice is that even though we had like a minor part of the lipids, it's like less than 4% or so, very small amount, we can see that it influences the surface fouling quite a lot in all three membrane types here.
Okay, so have you like measured the functional properties of the protein?
Not yet, not in this study. So the functionalities that I pointed out here are like based on what we know theoretically, that cruciferin is known for good gelling properties and napin as a good emulsifier and so on.
Yeah, like protein are very, very difficult to deal with, right? What you see in the theory, practically is very different. So that's why I thought like it might be, and even defeating one of the major issues with this protein functional properties. Another washout would be the flavor profile, whatever the protein you are getting, the flavor is a major washout.
When we use the setup, were you finished?
Yes, great. Thank you. Good presentation.
It was just in the future when we want to apply this setup on different concentrates, we also want to look more into the compositions. So both which type of carbohydrates do we have present in the different fractions, and also what about the nutritional components, glycosinolates and like polyphenols, which can cause health problems and also off flavors and so on. So this was more like a concept that I wanted to share.
Great. Well, thank you to our judges for asking questions. And Simone, thank you for your excellent presentation. And we'll pause now and get ready for our final presenter of this session.
Thank you.
And welcome back. And we have one final presenter for today, this first round of the student ePoster competition. A reminder again that our second round will happen tomorrow. And so look for those opportunities to participate as well. So our fourth finalist is Niraj Ganges, who will be presenting the talk, Impact of Extruder Die Temperature and Nitrogen Gas Injection on the Physical Quality of Soy Protein Meat Analogs. Niraj is a master's student in the Department of Food and Human Nutritional Sciences at the University of Manitoba. He received his bachelor's degree in food technology and management from the National Institute of Food Technology, Entrepreneurship and Management in India, and his research is focused on food extrusion and plant-based meats. With that as an introduction, I'll welcome Niraj to take the floor and provide us with his presentation. The floor is yours, Niraj.
Thank you, Dr. House, for the introduction. So when we talk about the animal-based food product, it is widely consumed as a protein-rich food, but it is related to various environmental, socio-economic, and religious concerns associated with it. With increase in the world population, which is expected to reach 9.7 billion by 2050, it will be a challenge to provide a protein-rich diet to the that population. And the solution for that is to use the plant-based protein-rich ingredient as food products. Various plant-based protein ingredients such as cereals and pulses can be transformed into products that have the that can mimic the texture of the animal-based products. And this can be done by using the high moisture extrusion cooking. We feed the protein-rich ingredient to the extruder that flows through the extruder barrel, converts into the melt, and when it passes through the long cooling type, it gets converted into a fibrous meat analog product. But the biggest challenge is to get textured product that mimics the meat texture of the meat analog. No one wants to spend their time on the barbecuing product that does not give them the textural quality that is similar to the meat product. So the idea behind my research is to incorporate bubbles in the matrix of the meat analog. And this can be done by a novel method, that is injection of the gas during extrusion cooking. And it is very easy and economic. Just require a small gas assembly with that is attached to the barrel to introduce gas in the matrix of the meat analog. And what we observed from the X-ray microtomography results was that when we compared the sample of the without gas injection and with gas injection, we can clearly see that there are a large number of bubbles in the matrix with the gas injection samples. And we also observed that the density of the meat analog was significantly reduced when we incorporated gas into the matrix. And another interesting result we observed was with the reduction in the dye temperature. With the dye temperature, we observed that density was significantly lower than that compared to at the higher dye temperature. So how it affected the texture of the meat analog? So when we analyzed the textural profile analysis of the meat analog, we found that the chewiness values significantly decreased with the gas injection at all dye temperature. And there was decrease in the trend of the chewiness values with decrease in the long cooling dye temperature. And similar trends were observed for the other textural properties such as hardness and gumminess of the meat analog. And for the degree of texturization, we found out that with decrease in the dye temperature, there was significant decrease in the values of the degree of texturization of the meat analog. So the conclusion of my research is that by using the gas injection during the extrusion cooking and by varying the long cooling dye temperature, we can manipulate the textural properties of the meat analog, and this can be easily done and is very feasible to do the extrusion with the gas injection. This is our research team led by Dr. Coxon. Thank you.
Welcome back, and thank you, Niraj, for that presentation. It was excellent work. Judges, it's time for your feedback and questions. Perhaps I'll start or ask our Mahfazer if they wanted to start with the questions first.
Great, thank you. So this is obviously a great presentation. So what is the chemistry behind increasing chewiness with temperature? So and the temperature you use the highest temperature 65, where I believe you have not even completely denatured protein, right? Even I saw that even like temperature 35 and 50, there is a difference in the chewiness. What is the chemistry behind this?
So I would like to clarify that the that temperature that I mentioned was of the long cooling dye. For the high moisture meat analog, we along with the extruder barrel, we attach a long cooling dye. The aim of the long cooling dye is to reduce the temperature below 100 degrees Celsius. And when it flows through the long cooling dye, there is the change in the flow profile of the melt, which was actually formed in the barrel. And that change in the temperature and the flow profile in the long cooling dyeing results in the formation of the fibrous texture. So actually the temperature, that flow profile changes when there is different long cooling dye temperatures are used, and that affects the texturization as well as the textural properties of the meat analog.
So is there any like increase or decrease in hydrophobic bond or disulfide bond?
So in my study, I'm not performing any of the chemical analysis. I'm more focused on the physical properties of the meat analog. And so the trend we observed was that with the decrease in the temperature, there was increase in the value of the texturization as well as change in the other textural properties.
Thank you.
Great, thank you. Elaine, would you like to ask questions now? Oh, you're on mute, Elaine.
Sorry. I'm okay now?
Yeah,
Yeah.
you're great.
Okay. Sorry. Very nice, Niraj. Is there any, I know you've done some organoleptic properties, like you looked at chewiness and gumminess. Is there any effect on the actual flavor? Has that been done with any of these products?
No.
Food grade.
In my study, this is the first time we are studying that how gas injection can affect the textural properties of the meat analog. This can be further analyzed with the different type of the gas and different pressures and changing the different source of the protein. But I'm not, my study is limited to the formation of the texturization of the protein and analysis of the microstructure and physical properties.
Okay, thank you.
Great, thanks, Elaine. And Carrie, do you have a question for Niraj?
Yeah. I guess following up on the previous question around the, why are you seeing the effects that you're seeing? I was wondering, do you have any hypotheses about why the temperature, why does the temperature have the effect that it does on the texture, within the density? You saw some pretty specific changes with and without N2, but also at different temperatures, interaction effects between the N2 and the dye temperature, the cooling dye temperature. I was wondering if you could just hypothesize a little bit about what might be happening there, mechanistically or chemically.
So actually still I'm analyzing the quantitative analysis of the microstructure of the X-ray images. But some of the samples that I analyzed, I found out that the shape of the bubbles that actually changed with the different dye temperature, and we observed that with the lower dye temperature, there was more elongation in the bubble shape. So, this might be because when there is change in lower, there is high difference in the temperature in the long cooling dye and the melt that enters the dye. So there will be change in the rate of the cooling of the melt, and that will affect the flow profile as well as causing the elongation in the flow. And I believe that is the main reason that affects the textural properties.
All right, thanks.
I'm just curious, sorry, coming back again. So is that elongation you are explaining, is it more from fiber or more from protein?
So actually the protein that converts into the fibrous structure, and the protein completely melts in the barrel, and when its temperature decreases below 100 degrees Celsius, the protein transform into the fibrous structure. And what I'm saying about the bubbles is that we observed from the bubbles is that those porous structure that was formed, there was elongation in those bubbles, and I believe that is also happening with the fibrous layer that is forming in the meat analog matrix.
Thank you.
Okay, Well, thank you very much, Niraj. We're going to now transition to our final Q&A session. So I encourage all of our attendees to put their questions in the chat room, or in the chat box, so that we can pose those during the final minutes that we have for this session. And we'll just take a quick break as we transition to that section. And welcome back to the final Q&A session for this, our phase 1 of our student ePoster competition for AOCS. We've had 4 excellent presentations today, and now we have some additional time to ask questions from the presenters. As well, I encourage you, as the audience, the poll for voting is now open. So I encourage you to vote for your favorite presentation. And that, again, will form part of the criteria that the judges, that goes into the final evaluation of the posters for final assessment. So let's get the ball rolling. We have some opportunity now to ask questions. I'll just open it up to our judges to see if there's any generic feedback that you wanted to provide to our presenters, or if there's additional questions that you had. Would someone like to start the ball rolling?
I could do that. First of all, I'd like to congratulate all the presenters today. They were all different talks on different aspects. So I think our audience got a real treat today to hear about various aspects of sustainable protein development. And everybody did an excellent job. That's why they were selected, obviously. And I'll reserve my questions for after. I'll let the other judges speak. But thank you very much for the work that you put into doing this excellent series of presentations.
Kerry, any thoughts?
No, I would like to. I'm curious to see what some of the audience questions might be.
Okay, and finally, Mafzer, any feedback or final questions that you might have for our presenters?
So I also would like to thank everyone. Really great presentation and good learning from all of you. You did great job. Thank you. And if there is no question from audience, then we can go for a discussion or ask question. I would like to see from audience first.
Yeah, I think we're a little light on questions from the audience, and so I think we'll basically rely on our judges to keep the discussion going for the next couple of minutes. Certainly, there's opportunity to ask additional follow-up questions on any of the topics, or even provide feedback on some of the presentations. But Mafzer, did you have some thoughts that you wanted to share?
So I am very curious about Simon's presentation on filtration. Like, which stage in the experimentation you are in? So you mentioned like you have not isolated protein yet, right? So which stage in the presentation?
Yeah, at which stage? I've been looking into the protein composition of the different fractions. And then the next step is to apply a new concentrate, the concentrate where I haven't degraded the carbohydrates, and then see whether that affects the selectivity and the performance of the membranes. So yeah,
so you are basically isolating the protein fractions, right? Not protein isolate as a whole.
Nah, yeah. I'm not. My aim is not to create like fully purified fractions or protein isolates. It's more to create functional fractions. So where the functionality, of course, is dependent on which protein is present there, but also maybe some interactions with the carbohydrates, for example, that could help on solubilizing some of the proteins and so on. So it's more to look into the interactions, the supramolecular interactions of the fractions and the systems that we create.
Thank you. Nice study.
Did your assessment also include a nutritional component as well, to look at some of the compositional from a nutritional standpoint?
I don't think that's really my expertise. We've quantified the amino acid profiles.
Okay.
Yeah,
That's a major step forward. So that's great. Yeah. Good.
Yeah.
I could ask a follow-up question for Mohammed. My question's around, you talked about activating the proteins with sonication. I was wondering, could you elaborate a little bit more on what physically is going on there? Is it are you increasing surface area? I mean, are you breaking the disulfide bonds, or how is it that this activation process is occurring?
So it's not about exposing more groups. It's like it's increasing the energy, because the molecules or the atoms are in a continuous vibration. So if we are providing them sonication, so it's kind of they are getting excited, you can say, because of the getting energy from the sonicator. So that's the main thing. Otherwise, I mean, it can help to enhance the reaction between them. It's not. It can help to break any bond. It's not that much energy to break any kind of bonding. It's like to get more excited, or because of that vibration, because the atoms or molecules are in continuous vibration. So it's increased that kind of energy.
So this is, you are basically creating protein and carbohydrate conjugation there, right?
Exactly. Yeah, you are right. Yeah.
Okay.
So yeah, it's between proteins carboxylic group and chitosan hydroxyl group. So it's ester linkage between these two.
Perhaps I could ask a question to Jannatul. Jannatul, I think this was addressed in the original questions that we were posed during your presentation, but I just want to get back to the co-product piece on the LCA, because I can imagine during the air classification process, what happens to that coarse fraction can have a significant impact on the LCA. So I don't know, how does the model deal with that? I know you talked about the current model, but if I were to use it as animal feed, for example, it would have a very different LCA footprint than if I used it for further fractionation or further purification. I'm just wondering if you could comment on that.
Yeah, so the integrated framework I was presenting, it was basically for the attributional part. So in the attributional LCA, we deal with the co-products, like we allocate the energy uses into the main products and co-products. We can use the mass-based allocation, or gross energy content-based allocation, or the last option is economic allocation. But for consequential LCA, we will consider the consequence of these co-products. Like if we want to use this fiber as animal feed or any other use, we have to deal with this multifunctionality using system expansion. So we will expand our system boundary and include that consequences in the analysis. So we will know that what are the environmental impacts associated with that co-products being used as animal feed. So that's the consequential LCA portion. But in the integrated framework, we are dealing with the attributional part, where we will just allocate the energy use or material use based on the mass or the gross chemical energy ratio of the products and the co-products.
Okay, thank you.
I have a question for Neeraj, if I may. I was just curious, since you're injecting gas, and that's a relatively novel approach for extrusion processes, is there any possibility of using that gas or any other gas as a carrier to maybe introduce nutrients or minerals or whatever, something to increase the nutritional value, or maybe a preservative, natural preservative for the purposes? Is that something that you considered?
For now, I haven't considered in that perspective, but I think that can be done. But the main consideration is that in the barrel, the temperature is very high. it can be up to 140, 150 degrees Celsius in the barrel. The melt temperature is very high. So we need to consider that there could be the loss of the compounds that are heat sensitive. So that is one of the biggest challenge to maybe encapsulate them in a way that they can survive that high thermal and shear treatment in the barrel. So yeah, I think that can be possible, but right now I don't know how we can do that.
Thank you. Thank you.
Okay, I think we've come to the end of our session today. I want to thank all of the presenters and the judges for their time and their excellent work today. We'll take a quick break and we'll do some closing remarks. So again, thank you all. And for those that haven't yet finished the poll or voted, please do so. And we'll be in touch with you in just a moment. Thank you all for joining us for part one of the AOCS student ePoster pitch competition. I think this has been an excellent session. We've had 4 great presentations. We're looking forward to 3 more tomorrow as we narrow in on our winner of the poster pitch competition. At this time, I'd like to thank the sponsors for this event. The support from CalSec and the Good Food Institute is invaluable to the functioning of this ePoster competition. So again, I'd like to thank CalSec and Good Food Institute for sponsoring this AOCS ePoster pitch competition. We hope that you will join us tomorrow for part 2 of the student ePoster pitch, which will occur at 11 a.m. Central Time. And we look forward to seeing you all tomorrow. So with that, I'd like to thank our judges, thank our participants, and thank our audience for coming to support these excellent presenters that we had today. And we look forward to seeing you tomorrow. Thank you very much.